Hello, this is the first video of the third vector series for OCR AS Core Pure Further Mathematics and introduces the vector product. There is more than one way to combine two vectors as a product. We already know how to find the scalar product of two vectors, which we have also called the dot product. And we remember that the scalar or dot product results in a constant number or scalar. Now we'll look at the vector product. This can only be used for 3D vectors, not for 2D vectors. Sometimes it is known as the cross product, and we use a cross symbol for this operation compared to the dot symbol for the scalar product operation in order to distinguish between the two products. To find the vector product of two vectors, we use the following definition, that A cross B is given by A2B3 minus A3B2 for the x component, A3B1 minus A1B3 for the y component, and A1B2 minus A2B1 for the z component, where vector A is given with xyz components A1, A2, A3, and in the same way, the vector B is given by xyz components B1, B2, B3. Let's look at an example. So 132 cross 342 will be A2, B3, which is 3 times 2 is 6, minus A3, B2, or 2 times 4, which is 8. And then on the next line, for the y component, A3, B1, 2 times 3 being 6, minus A1, B3, 1 times 2, A1, B2, 1 times 4 being 4, minus A2, B1, 3 times 3 is 9. This gives us minus 2, 4, minus 5. So note that unlike the scalar product that had magnitude only as a scalar or constant number, the vector product is a vector, hence it has both size or magnitude and direction. Note that we do not need to memorize the formula for the cross product or vector product, but it is important to apply it correctly. We will look at different methods of calculation in the next video. In this example, we are told that the cross product of 3k1 and minus 204 is equal to 12 minus 14, 6, and we are asked to find the value of k. We could, of course, just look at the x component of this product. Which would be 4k minus 0 for completeness. And we know that that equals 12. That would give us k equals 3. If we wanted to double check, we know that we are expecting the y component to be minus 14, but that's not going to involve k because it's going to be minus 2 minus 12. But at least we've checked that we're working out our vector product correctly. Instead of using the x component, we could have either used just the z component, or we can use the z component to check that k is indeed 3. So looking at the z component, a1, b2, minus a2, b1, we can see that that is 0 minus 2k. And we want that to equal 6. And k equals 3 does indeed work for that. So to find the value of k, we could have used just the first term, or the third term, or cross-checked using both. So the result of a vector product is another vector. and this vector is perpendicular to both of the vectors that we started with, or that we have formed the cross product with. This is a really useful aspect of the vector product, which we will return to in a later video. Now, if you go on to A-level, then you will find that the vector product, if it's written as n, is the normal vector to the plane that both vectors A and B lie in, remembering that normal means perpendicular. Now, the direction of the vector product, or n, is that of a right-hand screw. In other words, vectors A, B and n in that order form a right-handed triple. In the next video, we will look further at calculating vector products.